This presentation is about exercise, hiking, and metabolism. And I'm going to give you a bunch of scenarios that may have happened to you. For example, a hike coordinator says, let's go, starts off a pace or up an incline that you can normally handle easily, but you find yourself getting out of breath for a few minutes until you settle down and you get into a good rhythm. Why is that? And what should you do about it? Or another situation, you're strolling along nicely at a nice pace, chatting away, you feel like you could go on forever. Why isn't it always like that? You're climbing a hill and you start breathing heavily. Then after a while, you can't seem to get enough air and you just have to stop. After a break, you can go again, but then you've got to stop for a bit just a short time later. Why is that? What should you do about it? And then the situation, if you're in a long hike and you've been working at it pretty hard and you suddenly feel really tired, you're lethargic, there's no energy, and you have a really hard time going on. Why is that? What should you do about it? So let's start from the beginning. Energy for exercise comes from adenosine triphosphate, ATP. If you don't have any ATP, there's no muscle contraction and no activity. You can't move. However, only a very little bit of ATP can be stored. So it's going to be continuously resynthesized, and this is done in the mitochondria of your cells. And there are three ways in which this ATP is synthesized. First of all, you get it from the phosphagen system. You can get it then more slowly via the anaerobic production system, anaerobic glycolysis, or still more slowly via two methods of aerobic production, aerobic glycolysis or fatty acid oxidation. They're always all working, but which one is working most, in other words, what percentages there are, vary depending on the intensity and duration of the muscular activity. First of all, let's start with immediate ATP. It comes from ATP stored in the cells, or can be made very quickly from creatine phosphate stored in cells. The amount, however, is very small. It's enough for about 10 seconds of all-out exertion. And it's essential for initial activity or during short-term high-intensity activities, a sprint, a weightlifting movement, or for hiking, perhaps leaping across a stream. So the second method of production of ATP is anaerobic. Anaerobic means without oxygen. ATP is produced from glucose, or the stored form of glucose, which is glycogen. Glucose comes from carbohydrates. As I said, the process does not need oxygen, and it's a quite rapid production and can be used for high-intensity exercise for a few minutes, very few, say 3 minutes. It'll get you up steep hills quickly, but that's about it. Now, the problem with anaerobic production is there's an incomplete breakdown of the glucose, and that leads to pyruvate. At high intensity and low oxygen, the pyruvate is converted to lactate. The lactate changes the muscle activity, acidity, and this produces the fatigue with the burn, painful symptoms in your muscles. So the third method is two types of aerobic production of ATP. And this is what you need for any activity lasting more than about 3 minutes. It needs a continuous supply of oxygen. No oxygen, no ATP produced. The cell powerhouses, the mitochondria, use the oxygen and fuel, glycogen, to make ATP. Fuel comes in two forms. A carbohydrate is used initially for aerobic glycolysis. Well, what are carbs? Here's a table showing some different carbs, good, great, good, and bad. And I've got an asterisk on the bad because while they may be bad as part of your overall diet, they're not necessarily bad if for fuel for hiking in the short term. And then after about 20 minutes, after aerobic glycolysis takes place, you can move on to fatty acid oxidation. And that has a number of benefits, as we'll see in just a minute. Waste products of the aerobic production of ATP are carbon dioxide and water. Carbs, when they're being used, produce about 4 kilocalories per gram. Fats, on the other hand, are over twice that, at 9 kilocalories per gram. So fat is an excellent source of stored energy. Stored fat contains 50 to 100,000 calories. So you've got a lot of calories in your body, but while they can produce energy for the working muscles, they can't be used for the brain or blood cells. They need the glycogen. So, and the fat can't be converted to glucose and can't be metabolized unless some carbohydrate and oxygen is available. So the conclusion is you need muscle glycogen and blood glucose availability in order to continue to exercise at any intensity or duration. Now, at rest, both carbs and fats are used. The cardiorespiratory system easily meets the oxygen needs, and it's about 50-50 fats and carbs. However, with exercise, supplying the oxygen becomes more difficult. Aerobic glycolysis needs less oxygen than fatty acid oxidation. So as the intensity increases and oxygen becomes scarcer, the body burns more glucose, carbs, and less fat. And low intensity is 70-30, and higher intensity is 20-80 or thereabouts, as illustrated in this diagram here. So at rest, you'll see on the left about 50-50. At low intensity exercise, you're burning more fats than carbs. And as the intensity increases, you get the VT1, which is the crossover point where you're 50-50. At high intensity, you're now burning predominantly carbs. This is the basis of the whole fat burn region. In other words, low intensity region where you're burning fats more than carbs. Now you can use protein as energy. If you've gone for more than an hour and you haven't had any carbs ingested, your blood glucose levels begin to go down. After 3 hours, you may well become depleted in glycogen stores. And so protein can be broken down to produce energy. However, this is not good because the protein that's broken down is muscle. So you must take in some adequate carbs to fuel the exercise and ensure you've got a sufficient glucose supply so you don't eat your own muscle, in essence. Now, metabolic rehabilitation is training the body to burn a greater percentage of fats rather than carbs at rest and moderate intensities. Remember, at the low intensity, fats are burning. But if you can move that VT1 lower down, that will help out. And you do that by working at just below and then just above the VT1 threshold. That means moderate intensity for longer periods. So hiking at a rate where you can just about talk continuously is ideal. Training is nothing more than exercising a bit more than is comfortable. What happens is the body adapts to this uncomfortableness by improving. Concentrations of stored ATP and creatine phosphate increase. The ability to transport the lactate out improves. Your ability of your heart to pump more blood around and therefore get more oxygen to the muscles increases. And your ability of the muscle to utilize that oxygen increases. The number and size of the mitochondria increase. And so your cardiorespiratory endurance improves as well. So you can get more oxygen to the muscles and therefore produce more ATP. At low to moderate exercise, what happens is your need for oxygen increases immediately as soon as you start any exercise. The oxygen goes up, the heart rate goes up, stroke volume goes up, cardiac output is increased, your breathing rate goes up, your blood pressure goes up, your blood distribution changes away from processing your breakfast or your lunch into getting oxygen to the muscles. The problem is that your body can't respond instantaneously. There's a physiological time it takes for your body to change all the mechanisms to make it work. So you have this period of time between the start of the hike, start of the exercise, and when your body catches up. This is known as oxygen deficit. Then when you stop, you choose to stop, the reverse happens. You have some excess post-exercise oxygen consumption, known as EPOC. This, in essence, enables you to get free calorie burn without actually doing any further work. Now that's fine at low intensity, but what happens as the intensity increases? Again, the requirement for oxygen goes up, but unless you're extremely fit, your responds and you don't quite meet enough. You don't get enough oxygen, you cannot get to aerobic steady state, so you have to supplement with the anaerobic mechanism for producing the ATP. The lactate accumulates, attempts to remove, produces a lot of carbon dioxide, you get sake, you get the draw drop, and you basically run out of energy. You can only last a few minutes. Remember, 3 minutes with the anaerobic production mechanism. And so what happens is you have to stop. You just cannot continue. And again, the more you do this, you get a very larger APOC and a longer recovery time. So with this explanation, you got all the answers to those hiking questions. Let's go through them one at a time and explain what's actually happening. If you start off hiking at a pace you can normally handle, but you get you out of breath, why is it? What's happening? Well, you've burned off your immediate stored ATP. You're in anaerobic production of ATP. You have oxygen deficit, and later on you get caught up with the aerobic steady state, and you're meeting the need. I will illustrate this here in just a minute. So you need to start off a little slower for a few minutes to allow your body to recover and get to the aerobic steady state. So this is what's happening. Remember this oxygen deficit. So during that period of time between the black line and the red line meeting, you are not producing enough oxygen, you're going into oxygen debt, and you're getting the anaerobic issue. This period can last 10, 15, 20 minutes. And so if you start off slower and allow your body to get to that steady state, you will not have that problem. Same thing here. If you're chatting away, that means you're in a good aerobic steady state, then the oxygen needs are easily being met by your cardio system. Improving this by training will enable you to hike faster and steeper. So this is you normally. If you do some training, then you can do more with still meeting your oxygen needs. So what's happening when you're climbing a hill and you have to stop? Well, again, your intensity level is high enough that you're now in the anaerobic region of ATP production. Your cardiorespiratory can't meet the oxygen needs, and so you have all the lactate buildup issues. So what do? Well, you have to slow down. Take shorter steps, go slower, reduce your cadence, and in other words, adjust your level of effort to that which meets your ability to produce oxygen. And what you can do if you want to be able to hike harder and faster and steeper is to do some training to increase the cardio capacity. So this is what's happened. Remember, your intensity level is high enough that your oxygen needs are not being met. So you've got to stop or come down in intensity till you're at steady state again. And then the last time situation here is you're doing a long hike, and we're talking more than 3 hours at this point, perhaps, and you suddenly are totally out of energy. Well, the reason is you ran out of fuel. They call it bonking, and you don't have enough glycogen left in your body to produce the ATP. Fats are still available, generally speaking, but you've got to have some glucose to metabolize those fats. So the bottom line is you've got to eat or drink carbs. However, there's a limit to the rate of uptake of those. So you have to eat or drink the carbs before you bonk. There's no point running out of fuel and then gassing up. You've got to gas up as you are going along so it's available for when you need it. And if you look at different burn rates, you can look at how heavy you are. For me, I'm about 170 pounds, which means that when I'm hiking uphill with about a 10-pound load or thereabouts, I'm burning about 500 kilocalories an hour. Now, we can only store about 1,000 to 1,500 calories of glycogen in our bodies. So if I'm burning at a 500, that means I got 2 or 3 hours before I've depleted, exhaust my glycogen supply. So basically, I run out of fuel in that period of time. So, but again, you can't wait until you run out before you start taking in fuel. Ideally, if you are going to be doing a very long hike, taking many hours, then you should think about carb loading beforehand. You should think about taking in sufficient carbs. And the recommendation is every 15 to 20 minutes. Depending on the duration, you can see the number of grams per hour that you might need to take in. And then afterwards, you need to take in some more carbs, but you also at this point need to take in some protein. So this is, again, mostly not going to impact people on a short club hikes, 1 to 3 hours. But if you're doing a marathon, doing a really long hard hike, then think about timing of the fuel significantly. So what does 60 grams an hour look like? Well, here are some grams of carbs for a variety of favorite hiking snacks. For example, I like to eat an orange. Well, an orange only gives me about 15 grams of carbs, about 60 to 100 calories, depending on the type of size of the orange. So this gives you some idea of how much you've actually got to be eating or drinking to maintain a long hike. So for your standard club hiker, takeaways from this metabolism talk: start easy for the first 10 or 15 minutes. Let your body catch up. Stay within the aerobic capacity. You can tell this if you're below your VT1 by the fact you can talk continuously and easily. If you get above your VT1 and you're burning the fats, you can't be talking as easily. Eat carbs frequently. You don't eat on a hike because you're hungry. You eat to keep gas in the tank. If you want to improve your hiking ability or do something more strenuous than you normally do, then you need to train at a pace that makes talking difficult, above the VT1 threshold. You need to train at elevation if that's where you're going to be hiking, and at distance if that's what you're going to be doing. So you need to do something that approximates what you're trying to do. If you want to be able to do an 8-hour hike up at 5,000 feet, then train at those types of distances and elevations. Eat about 20 grams of carbs every 20 minutes or so. So now you know all about hiking and metabolism, and you can hike smarter.